On April 6, 1993, a China Eastern Airlines MD-11 aircraft was preparing for baggage and cargo loading for a very long overnight flight. The flight, numbered MU583, was scheduled to travel from Shanghai, China, to Los Angeles, USA, covering a distance of over 10,500 kilometers. The estimated flight duration was approximately 11 hours and 10 minutes. The captain, whose identity was not disclosed, was 42 years old with 8,535 flight hours, including 1,431 hours on the MD-11. He was a mainland Chinese pilot trained in China, holding licenses for Airbus, A310, Ilyushin 14, and MD-11. The first officer, also unidentified, was 43 years old with 9,714 flight hours, including 199 hours on the MD-11. Despite having a considerable duration as a pilot, the first officer had only received his MD-11 type rating 5 months before. The flight carried a total of 255 individuals, including 235 passengers and 20 crew members. The aircraft operated for this flight was an MD-11 with the registration number B2171. It had its maiden flight in 1991, making it just 2 years old at the time of the incident. The aircraft had accumulated nearly 5,000 flight hours. The McDonnell Douglas MD-11 is a wide-body passenger aircraft with 3 jet engines, introduced in 1986 with an immediate order of 52 units. Compared to other aircraft types, the MD-11 has a relatively high cruising speed, attributed to the design of its wings with a large sweep angle. In an effort to balance costs, the manufacturer attempted to modify materials in certain areas deemed controllable. However, optimizing cost design on a complex trijet aircraft posed significant challenges, leading to numerous hazardous issues upon its public debut. Similar to other commercial aircraft, the horizontal tailplane of the MD-11 bears significant pressure during operation. The material used for the tail section was replaced with a more cost-effective compound, rendering the MD-11's tail sensitive to high pressures. Consequently, McDonnell Douglas intentionally shifted the aircraft's center of gravity rearward to alleviate pressure on the tailplane, ensuring balance with the heavy third engine. This compromise between shifting the center of gravity rearward and maintaining stability posed challenges for the aircraft. McDonnell Douglas emphasized the need for thorough training in manual control for MD-11 pilots, recognizing the complexity of handling this aircraft. Unlike modern commercial aircraft, an essential control system installed is static stability, which helps maintain stability during steady flight. Suppose the aircraft is flying steadily, and suddenly, the pilot pulls back strongly on the controls. Instead of immediately pitching up, the computer will take control of the aircraft to respond at an appropriate rate, gradually adjusting to avoid posing a danger to the flight. This system is not equipped in fighter jets, which require high agility and immediate response. The MD-11, lacking static stability, makes it challenging to control like a fighter jet but carries additional passenger capacity. Due to its diminished stability, the MD-11 initially faced challenges, including failing a stall test and being denied flight certification. However, subsequent modifications have brought this aircraft type back into the market, with a total of 200 units manufactured globally. Five hours after takeoff, Flight MU583 had covered half of its journey. The MD-11, carrying 255 people, was soaring over the vast expanse of the Pacific Ocean. Designed to operate at high speeds, the current Flight MU583 is flying at a cruising speed of 1,012 km per hour. This is the typical cruising speed for the MD-11. After the passengers had their dinner, the flight crew, with the captain being the first to finish his meal, is now having their own meal, and the captain returns to the cockpit. The aircraft's wings are designed with a distinctive shape to generate lift as the aircraft glides through the air. However, at different airspeeds, the wing configuration varies. Whether flying too fast or too slow compared to the designed wing configuration, both situations lead to a loss of lift. At low airspeeds during takeoff and landing, the aircraft's wings are typically configured with wing flaps. These flaps aid in generating significant lift at lower speeds and are specifically employed during the takeoff and landing phases. If wing flaps are used at high speeds, the lift is compromised, and instead, drag is introduced. After finishing their meal and returning to the cockpit, the captain sat in the first officer's seat to relax. Suddenly, he noticed an abnormal indication on the screen. The computer was demanding that the pilots fly at a speed lower than their normal speed, which was highly unusual. The captain proceeded to check the flight management computer. As the captain was seated in the first officer's position, he used the first officer's side of the cockpit to operate the computer. In the midst of trying to check quickly, the captain inadvertently activated the wing slat system. Due to intense concentration, he did not immediately realize it. However, something more frightening was unfolding. The wing slats of the aircraft began to deploy while the plane was flying at over 1,000 km per hour. If the aircraft is flying too fast compared to the wing's configuration, it leads to a loss of lift. The first officer and captain had just stabilized their positions when the aircraft issued an overspeed warning. The warning sound confused the pilots. It was at this moment that the captain glanced back at the speed control screen and was surprised to see the wing slats at a 10-degree angle. However, what was even worse was that the aircraft was rapidly losing speed due to the drag from the deployed wing slats. The captain quickly retracted the wing slats, but it was too late. The drag caused the aircraft's speed to continue decreasing. After the maneuver, 25 seconds passed before the slats returned to their initial position. The speed had dropped too low, leading to an unstable condition where the autopilot disengaged. Due to the loss of lift from the main wings and the nose being pushed up, the aircraft entered a state of aerodynamic stall. Flight MU583 entered a state of aerodynamic stall and lost control. The aircraft began to descend, challenging the pilot's efforts to save the MD-11. The captain initiated a pitch-up maneuver to raise the aircraft's nose.
Speed. Lap over speed.
However, the MD-11 responded more dramatically than the captain intended. With the nose pitched up excessively, the aircraft entered a second stall condition. more severe than the first. Passengers and luggage were thrown around the cabin. Once again, the pilots managed to pull the nose up.
Land over speed.
But the MD-11 continued to struggle, and the nose was pushed up too high. The flight crew facing a third stall condition. The flight crew decided to take control, steering cautiously and gradually to avoid the aircraft's overreaction.
Speed. Overspeed. Overspeed. Overspeed.
This time, the aircraft slowly returned to a safe state. The flight crew engaged the autopilot to climb back to an altitude of 35,000 feet for damage assessment. Flight attendants reported numerous injured passengers, some of whom were unconscious and bleeding. Unfortunately, there were no civilian airports in the middle of the Pacific Ocean where they could land. The captain requested permission to land at the Shemya Air Force Base in Alaska, USA, and the request was approved. Due to the need for an emergency landing mid-flight, and sufficient remaining fuel, the crew conducted fuel jettisoning to ensure a safe landing. About 2 hours later, the aircraft began its approach to Shemya Air Force Base. The crew requested the preparation of ambulances and firefighting vehicles for the emergency evacuation process. The landing needed to be precise, as the military base's runway was only sufficient for the MD-11 to land. Flight MU583 safely landed at Shemya Air Force Base in Alaska, USA. However, 2 out of the 255 people on board lost their lives due to injuries caused by the violent acceleration of the aircraft, impacting baggage and the cabin ceiling during the incident. The governments of China, and the United States National Transportation Safety Board, along with the aircraft manufacturer McDonnell Douglas, conducted an investigation into the accident. The unintentional activation of the wing slats at high speed by the captain led to a sudden loss of lift, causing the flight to enter a stall condition. According to the statements provided by the pilots, the MD-11 reacted excessively to their commands. However, from the manufacturer's perspective, McDonnell Douglas asserted that the pilots had inadequate control over the aircraft. In the investigation involving other aircraft of the same type, investigators discovered that there were at least 10 flights where pilots inadvertently activated the wing slat system. However, in all 10 cases, the pilots managed to rectify the situation before the system fully deployed. Subsequently, investigators recommended that McDonnell Douglas should modify the design of the wing slat lever in the cockpit. Instead of making design changes, McDonnell Douglas issued revised guidelines instructing pilots to exercise greater caution during operations. Additionally, they introduced specific procedures for handling this particular issue in the training of MD-11 pilots. Like and subscribe for more videos.